All right, number 134. We are going to use the distributive property. Let's take the first term x, multiply it by each term of the trinomial. So we have x squared, 2x, and 1. And then we're going to take the second term in the binomial and distribute it to the trinomial also. So that's negative 2 multiplied by each term. And let's solve each one of those. So x times x squared is x to the third power. And then we have x times 2x, which is positive 2x squared. X times 1 is positive 1x. Then we have negative 2x squared, negative 4x, and negative 2. Now we're going to look for all of the like terms to combine, which we are looking at the exponents of each term. We have x to the third power. Anything to the second power, we have 2x to the second power and a negative 2x to the second power. And when we put those together, we end up eliminating them. So we have 0x to the second. Now let's look to the x to the first. We have positive 1x to the first and negative 4x to the first. So when we combine those terms, that's 1 and negative 4, which is negative 3x. And our constant does not have any like term with it, so we end with negative 2. Final answer. Number 135, we have a binomial squared. So if we were to write that out, it would look like the quantity of a plus b multiplied by the quantity again of itself, a plus b. We're going to use that same distributive property. I have not taught you the FOIL method yet. That would probably be a little bit easier in this case, but let's just stay with what we've been learning. So let's take our first term a and multiply it by each term on the other side. We have a multiplied by a and a multiplied by b. Take our second term b, do the same thing. We have b multiplied by a and b multiplied by b. Solve those. We have a squared. We have positive 1ab. We have another positive 1ab. And then we have a positive b squared. Let's combine like terms. A to the second power is by itself. We have a positive 1ab and another positive 1ab. Put them together. We have a positive 2 of them. Positive 2ab, and then just a plain old b squared by itself. Final answer. Number 136, same idea except we have a difference here. We have a subtraction sign. So written out, this means the quantity of a minus b multiplied by itself. And let's distribute. A times a times negative b times a, and then negative b times negative b. A squared minus 1ab minus another 1ab. A negative times a negative is a positive b squared. Let's combine like terms. A squared, we have minus 1ab, and let's put it with another minus 1ab, which gets us minus 2ab plus b squared. Final answer. 137. Let's multiply these. Same idea. Okay, a squared uh, plus 1ab minus 1ab, and then a negative b squared. So we're going to lose the middle term here. We have opposite signs. A squared, a positive 1ab put together with a negative 1ab. You have lost that term because positive 1 and a negative 1 is 0. So we just bring our negative b squared over. We call that a difference of two squares. That's actually a special rule, special product rule. All right, now number 138 gets a little bit more tricky. So we're going to be working that product rule in reverse. It's called factoring this trinomial. So we're actually going to try to go back into a product of two binomials, and we need to figure out what those two binomials are. Teachers teach this in different ways. A few years ago, I learned this X method, and the X method kind of deals with the FOIL that I haven't taught you yet, but maybe it can make a little bit of sense if I just show it to you here. So if I'm following the FOIL method, I have F in my first column going down. I have O and I in my center, and then my last column going downward, I have the L, so we have FOIL. And what I'm going to do is I'm going to look at the coefficient in front of my x squared, and I'm going to put all of the possibilities of that first coefficient. The coefficient is 1, and what are the numbers that multiply together to get 1? Well, that would be 1 and 1. So when I multiply my first column down, 1 multiplied by 1 will get me my 1x squared. And then the second column is a little bit more difficult because if I'm looking at this 15, I need to come up with all of the factors that multiply together to get 15. Well, that would be 1 and 15, and that would be 3 and 5. So I'm just going to make a bunch of x's that incorporate all of these different possible products. Well, I can do a 1 and a 15, and then on the converse to that, I can go 1, 1, and then mix and match that second column of 15 and 1. Now, that's not really necessary in this problem, but as we move along with different coefficients, you're going to need that. All right, so if I multiply straight down, I have 1 times 1 is 1x squared. 15 times 1 does not get me a negative 15. It does get me a positive 15, so we're going to have to mess around with some signs here also. But then when I look at this O and I in the middle, the cross products need to add together to get your middle term of positive 2. So when I have 15 and 1, there is no way I'm going to be able to get a positive 2 or any type of 2 out of that sum. So let's make a couple different x's here. Let's make the x's of 1, 1, and our other factors, which would be 3 and 5, or maybe it'll be 1 and 1, 5 and 3. And again, since we have this little negative in here, that's going to play tricks on us. So multiplying our first column down, I'm still going to get my 1x squared. Multiplying my second column down, I'm going to get some kind of 15. If one of my negatives, or if one of my terms are a negative, I will get a negative 15, but I need the sum in the middle to equal a positive 2. So how are we going to mess around with that? Well, play with the signs a little. I know that when I add two terms and I get a positive 2 in the center, I'm going to need my larger number to be the positive. So in this case, it's going to be a positive 5. In the other case, I'll need a negative 3. Now let's check that. If I multiply straight down, I get 1 times 1 is 1x squared. My last term down, I'm going to get negative 3 times positive 5, which gets me my negative 15. So that works out. And it's all going to come down to the center sum of this cross product. Well, what's 1 times 5? That's positive 5. What's 1 times negative 3? That's negative 3. When I OI them or add them together, I am going to get my center of a positive 2. So when I write my final answer, let me clear some of this off. Actually, let me clear all of this off. Anything we don't really need here. Let me rewrite it, make it look a little neater. I have this x. I have my column down getting me my 1. My second column down, I had a negative 3 and a positive 5. Well, simply stated in your answer, you're just going to take your parentheses on the top and your parentheses on the bottom, and you have your answer. Well, 1 what? We have 1x minus 3 multiplied by 1x plus 5, final answer. Number 139, this is the same idea, and I warned you about the coefficient being more than 1. In this case, the coefficient is a 3. All right, let's get a bunch of these x's going. What's going to get me a 3 going down the first column? Well, a 1 and a 3 and nothing else. What can get me a 10 going down the second column? A lot of options. I can go 1 and 10. Let's get the buddy to that. 1, 3, 10, and 1. We're going to worry about the signs later. And maybe in a different color, I know that I can list a 1 and a 3, and how about a 2 and a 5? And let's get its buddy of 1, 3, and reverse that second column. Now you don't have to reverse the first column because you're already mixing the partners in the second column. All right, let's see if we can eliminate any of these. I need a product down the columns to get 3 and 10, but more importantly in the center, I need these two to add up to get a positive 17. Well, we got very lucky here because all of the signs are positive, so we don't need to worry about any negatives in here. All right, so 1 times 3 gets me a 3 coefficient, that checks. 1 times 10 gets me a 10 constant, that checks. Let's add these up. So 1 multiplied by 10 is 10, 3 multiplied by 1 is 3, and I cannot get a 17 out of 10 and 3. So these are eliminated from our choices. Looking at the next choice, same idea, 1 and 3 gets me a 3 coefficient, 2 and 5 gets me the constant of 10. Now, all of the signs are positive, so I can put in a positive. And which one is going to get me 17? So let's do our cross product rule. 3 multiplied by 2 is 6. 1 multiplied by 5 is 5. When I put them together, I do not get 17. The other option, 3 times 5 is 15, and 1 times 2 is 2. Can I put those together to get 17? And the answer is yes. So we have found our answer. It's not the top one. Let's get our parentheses rolling here. Oops, sorry, shouldn't erase that. So we have the first one, which is 1 what? We have 1x, and the partner is a positive 5. And in the second one, we have a 3. 3 what? That's 3x, and its partner is a 2. Final answer. If you wanted to check this, go back and do your distributive property 2 times like we've been working on, and it will come out to this trinomial. Number 140. This is a special rule here. This is called a difference of 2 squares. I notice that my x is a square, my 81 is a perfect square, my 4 is a perfect square, and there's a difference. So when I'm breaking this down, the quick rule to this, factor out any common numbers if possible between 81 and 4. There aren't any common factors, so we're going to just keep it as 9x, and 9x will get me my 81x squared. 2 and 2 will get me my 4. There's my perfect squares. And then how am I going to eliminate that middle term? Because if I don't eliminate the middle term, I'm going to have a trinomial. But in my original problem, I have a binomial. So eliminating that middle term will have opposite signs. Final answer. All right, number 141. We have a polynomial with 4 terms. Looking to factor out anything, well, we can't factor out any coefficients and we can't factor out any x's, but what we can do is we can do a grouping system here. So I'm going to take a grouping symbol system of, someone get that please. We're going to take this grouping symbol, make sure that our exponents are in descending order, and they are. So third power, second power, first power, and down. So I'm going to use parentheses here to group these, and I'm going to factor out common x's. So what's the most amount of x's that I can factor out of the first binomial? And that common x, the largest x that they both have would be x to the second power. So I'm going to take one of them out. And what would I be left with on the inside if I took x squared out? Well, x squared times x is x to the third, and x squared times positive 1 would get me my positive 1x squared. And then on the other side, I can't factor out anything common, so I'm still left with this x plus 1. Well, how is that going to look as a final answer? We have a shared x plus 1 quantity, so we're going to take the outside items, the outside monomials, and pull them into our answer. So I have x squared on the outside of the first one, and I have a positive 1, which is invisible, on the other binomial, and then we're going to multiply that by that shared answer. Just take one of them down, x plus 1. That's the final answer. You can go back and check it if you want to, use that distributive property, and you're going to end up with that original polynomial. Number 142 is the same idea. First of all, you have to hunt down any common factors that can be taken out. Since they're both even numbers, I know that I could take a 2 out, and I'm going to do that. So 2 factored out, I'm left with 25x squared minus 1. These are both, this is a difference of 2 squares, so I can break that down. 2 multiplied by what? Well, the perfect squares are 5x and 5x. The other perfect square is a 1. I need them to cancel because it's a binomial. So I'm going to alternate the signs, and that will lose that middle term. Final answer. Number 143 is the same idea. Let's factor out all common x's and all common factors. And it looks like I could take a 3 and how many x's can I take out? Well, this has 3, this has 2. Well, they all share only 1 for sure, so we can only take out 1x. So common factor of 3, 18, and 24 would be a 3, and only 1x is possible to take out. That's the highest amount that they all have. And now what's going to go back inside? Well, 3x times x squared gets me 3x cubed. 3x times positive 6x gets me 18x squared, and positive 8 will get me my positive 24x. And now we look to see if we can break down this trinomial, and we can. So that's going to be using the x method once again. So 3x multiplied by what 2 binomials are going to get me this trinomial. Go ahead and use that x method that I taught you. It's going to be x and x. And I know that 2 and 4 will get me 8, and the sum will also get me 6. So some kind of 2 and 4. Let's look at the signs. We have both of them being positive, and that is your final answer. So you're factoring out the most amount of x's and the greatest common factor, which happened to be 3, and then you keep working all the way down to its lowest factored terms. Okay, that is it for this back page of the packet.